Class, this week we take on the toughest topic in the unit: reliability, validity, and utility. Yeah, the three principles of HR measurement. These principles will underpin the next several weeks of this unit on selection, as well as all of the assessments moving forward. I will try my best to make these topics digestible and not too dry, but if you find you're having trouble, class, I recommend reading the associated chapters in the textbook first. So, this lecture is divided into two parts. Part 1 introduces the notion of HR measurement and goes through the first principle of reliability. Part 2 covers the second and third principles of validity and utility, respectively. Now, class, we are presumably all familiar with the words reliability and validity. Yeah, these are two fairly common English words with straightforward meanings. But I'd like you to set those meanings aside because that can be deceptive. Yeah? Bear in mind that in an HR or measurement context, the words reliability and validity are a form of jargon with very specific meanings, yeah? So let go of your assumptions and baggage about these two words and prepare to encounter them in a totally new way. Now, class, the whole point of HR selection is to hire people who can do the job well, yeah? The best fitting person for the job. So how do you work out who has what it takes to do any given job well? Yeah, maybe you can do some interviews, ask them some questions about themselves, their experience, their training, their background, their skills. Yeah, you can also look through a record of the things they've done in the past, according to them. Yeah, their resume. You can judge their first impression, their handshake, how they present themselves when you first meet them. Maybe that'll give you some information about who they are. You could have them do some tests, maybe a personality test or some sort of like puzzles, for example, yeah, like in an IQ test. You can ask other people, hey, what do you think about this job candidate? Do you reckon they're good? Similar to this is asking for references, yeah? And you can gain some insight from doing that, presumably. Or you can simulate the job environment for them and see how they perform, see how they handle it, yeah? Lots of different things we can do to work out who can perform a job well. Now, why do we do any of these things, class? Presumably, in principle, it's because these things, interviews, resumes, and so on, give us insight into the job candidate's knowledge, their skills, their abilities, and their personality. Yeah, they're KSAOs. Yeah, they also provide incidental information, stuff like will this person be pleasant to work with? Yeah, this is stuff that's, I guess, good to know. Doesn't necessarily predict performance, but it's stuff that can be valued by interviewers or valued by HR officers, regardless. Yeah. But their class is the critical bit, yeah? It's information. All these selection procedures, interviews, resumes, references, everything else, these are all data gathering exercises in some form. And this is true regardless of whether, regardless of whether the HR officer or the interviewer is consciously aware of it. Yeah, like you might be coming into an interview just wanting to wing it. Regardless, the same fundamental principle from the HR officer or supervisor's perspective is gaining information about the job candidate. Yeah? Now, these selection tools are informative, but some will be more informative than others. Yeah, undeniably. Maybe the strength of their handshake might prove to be more informative than what they say in an interview or a report in a personality questionnaire, yeah? Maybe we should be using handshakes for selection. Class, these are questions that we can answer by collecting data, yeah? By doing a bit of science. The data will tell us which selection tools actually do their jobs, which are, number 1, providing information about the job candidate's KSAOs, yeah, their knowledge, skills, abilities, other characteristics, and number 2, predicting the criteria that matter, predicting who is going to be successful at this job. Now, class, ultimately what this means, is that a solid selection tool helps us do something that is pretty wild, It lets us read people's minds. That, in a nutshell, class, is the fundamental challenge of HR selection, which is we are trying to be mind readers. We want to see what KSAOs the minds of job candidates contain, we're reading their minds and to some extent their bodies, if that's relevant to the job, but generally it's their minds. So class, bring out your crystal balls and your tarot cards and join me in a journey into the minds of our job candidates. So, class, we're going to go over principles of measurement, of measuring the mind of job candidates, of anyone, Let's start with the definition of measurement, Measurement is the systematic application of rules for assigning numbers to people to represent the quantities of their attributes or traits, Now, as per usual, let's pick this definition apart. First, measurement is the systematic application of rules. Systematic, class. So any selection technique is systematic and purposeful, The more purposeful, the better the measurement. Application of rules means that there's a decision process that goes into making sense of what comes from the selection tool. Next, for assigning numbers, any selection tool wants to precisely evaluate KSAOs, and to do so precisely, we quantify them. Now that quantifying can vary in how precise it is, but generally there is some quantifying going on. Next, we do this to people. Yes, we do this for job candidates. We're rating them on their KSAOs. And we do so to represent the quantities of their attributes or traits. The idea here, class, is that any knowledge, skill, ability, anything is something that varies from person to person. Some people are more extroverted than others. Some people have better math ability than others, etc. All these things can be quantified. And we are able to do this because people are different. There are individual differences. Some people are better at math than others. Some people empathize with customers better than others. Some people are better at using accounting software than others, And the whole point of the selection process is to capitalize on these individual differences and select employees with the right individual differences for the job. Now we do so using selection tools that are able to measure and quantify the KSAOs. And again, we do this because we believe and know that people are different. If everyone was the same, it would not matter. Selection would be pointless. Just pick anyone at random. However, because individual differences do exist, and these individual differences do predict performance on the job, we wanna select people who possess the right differences. Okay. Now, class, a quick recap from last week. Criterion. These are the things we tried to measure. The criterion is our definition of success on the job. Typically, supervisor ratings of work performance. Now, bear in mind, class, that most jobs have multiple relevant criteria. There are jobs for which the most relevant criteria might be supervisor ratings of work performance, as well as team performance, and maybe low levels of theft. Any given job can have multiple criteria, and you want to select a job candidate who is able to meet these criteria. Next, we have the predictors. Predictors are our selection tools, and these are effectively measures of KSAOs, and the KSAOs are identified through a job analysis process as being important for job success, like in the job analysis interview or critical incident technique or job analysis inventory. We work out what are the things they need to do on the job, data people things, and try to assess using selection tools that are able to pick up the competencies for doing the job. Yeah. Now, class, collectively, we refer to criteria and predictors as constructs, and these are things we try to measure. Yeah, we need good measurement for these things. For criteria, we use good measurement of criteria in performance evaluations. Yeah, you want to know who's been doing the job well. You need good measures of all the things that capture success on the job. Yeah, and in the selection process, we really focus on having good measurement of predictors. Now, class, there is a problem. Yeah, no selection tool is perfect. So let's say you're conducting a behavioral interview with a job candidate for a bookkeeping role. And you're asking them questions about their time management ability, because you need to see if they can manage their time carefully, especially as a tax season comes to a head. Yeah? And so you ask them this behavioral interview question. Tell me about a time when you needed to complete a task in a limited time and with a tight deadline. Yeah? Fairly standard behavioral interview question. Now, class, the job candidate's answer will give us some insight into their genuine time management ability. Sure, so we can determine which job candidates manage their time better than others. But that's not, and presumably that will predict their performance on the job. But that's not the only thing that influences their answer in the interview question. Yeah, there are other things that interfere in the process. For example, some job candidates might exaggerate their answers or make stuff up. Others may have interview anxiety, and so stuff up their answers even though they would generally manage time well. Or maybe they're just naturally more confident. Yeah, they have more self-efficacy. Or maybe they benefit from cultural stereotypes for being good at the time management, so their response looks better. Yeah, so there are heaps of factors that can potentially interfere with the relationship between our selection tools and our criteria. Okay? Now, class, one neat way for thinking about this, one nice heuristic framework is classical test theory. Yeah, it gives us a framework for thinking about measurement and noise. Yeah, every selection tool will give us some like score. Yeah, you can listen to someone's interview and give them a score, just a genuine judgment of how you reckon they did. Now that you can judge the job candidate's time management based on their answer. Now that observed score, the score you give them, will be a mix of a couple things. It'll be a mix of their genuine time management ability, yeah, as well as some other noise. It could be noise in your evaluation of the job candidate's answer, maybe your own biases, maybe just the subjectivity in the process. It could be stuff to do with the job candidate, maybe their interview anxiety, or maybe they're exaggerating. Now, some of this noise is random and simply due to chance, yeah? Others will be more like a systematic bias that gives some people clear advantages and some people clear disadvantages. Yeah? Now, ultimately, the thing we want is a measurement of the true score. Yeah, because their true time management ability is what's going to matter on the job. Yeah, so what we want is good measurement in which there is we're clearly capturing their ability. There is minimal error and noise, and so that way the score we give them is closely capturing their actual, in this case, time management ability. Okay, we want minimal noise and lots of true score. So, what are the things that can contribute to error, class? There are heaps of factors. There's the examiner, the person doing the interviewing and making the evaluations can have biases or just subjectivity or just not thinking through what is a good answer to the interview question. Yeah, you would be surprised, class, how many interviewers rock up to an interview, ask questions, not knowing what a good answer is supposed to be. Seriously, it's a real problem. And when you do that, a whole heap of noise comes into the picture and contaminates the score from the interview, so it doesn't capture true score and kind of just captures noise. Yeah. Then there's the sample. Yeah. Who is going through the selection process? The test taker themselves. The situation. Maybe there's a lot of background noise during the interview. Maybe it's a particularly stressful situation. Yeah. There's also the culture and the industry. So lots of factors can come into play and introduce discrepancies between the true scores on any KSAO and the measured scores in our selection tool, thereby increasing error in our measurement. So how do we choose and develop selection processes that have minimal error and that really let the job candidate's true scores shine? Now, class, there are 3 broad aspects of good measurement. Yeah? Reliability, validity, and utility. Reliability, class, refers to the consistency of the measurement. Does the measure have minimal random noise? Yeah? Validity refers to the accuracy of the measurement. Does the measure have minimal systematic noise or systematic bias? So reliability is random noise that makes the measurement very crude and imprecise, unable to really get at a precise understanding of the true ability of the job candidate. With validity, a measure that lacks validity is going to systematically inflate scores for some people and deflate scores for others. Yeah, so it's creating bias. And then we have utility, class, which is the usefulness of the measure in terms of value for money. Yeah? Let's go through a few examples. Let's say you want to work out a person's sales ability. Yeah, their ability to do well in a sales job. Yeah, their selling competencies. And you do so by assessing the quality of their handshake. Yeah, how good is their handshake? That is a pretty crude and rough measure at best, yeah? And that would get you in the upper right quadrant where, yeah, I mean, maybe to some extent, the quality of the handshake might predict sales performance, but people might not agree on what a good handshake is. What you're gonna get is a very crude and imprecise measurement that's all over the shop, yeah? The other approach is, you wing it as a job candidate. You just rock up to the interview, chat with the job candidate about stuff that's interesting in their resume, and you see if they wow you, yeah? Now, the problem with that approach is that it's not only noisy and inconsistent, as you can see here in the upper left quadrant. It's noisy and it's inconsistent. It's also affected by your own biases. Yeah, so your biases will inflate scores for some people, maybe deflate them for others, but perhaps mostly inflate. Yeah? And so in this case, we have measurement that's neither reliable nor valid. Then, let's say instead, you want to measure sales ability by asking them, hey, which uni did you go to? Presumably, if they went to a good uni, they'd be better. Yeah? You see this sort of argument play out in lots of jobs, lots of industries. They like students from Group of 8 unis. Presumably, that's why you're at UWA. Yeah? Now, the thing about asking people what uni they're from is that's pretty precise. Yeah, there is not going to be a lot of error where, like, I guess people could lie, but you could get their transcripts, and there's lots of ways to cross-validate and confirm, I should say, that this person did go to the uni they claim they went to. Yeah. Now, the trouble is, while you can work that out precisely, it's a very biased way to measure potentially sales ability, yeah, because it's systematically biased against disadvantaged students, yeah, who couldn't go to a Group of 8 university. So here we have a case of the lower left quadrant, yeah. It has low validity because it's biased, yeah, it's systematically biased, but it is reliable because it's easy to consistently measure which uni the person went to. And lastly, we have really the only acceptable kind of measurement for HR contexts, which is measurement that is consistent. We can easily come to agreement on what a good score is, and that doesn't have systematic bias one way or another. Yeah, it's not like a handshake where working out what a good handshake is not going to be clear or consistent, nor is it going to be asking people which uni they went to, which will be easy to assess consistently, but definitely going to be biased. So, let's start with reliability, class. In a nutshell, reliable measurement is consistent. Yeah, it's dependable and gives you the same result approximately, no matter how you slice it. Yeah, so here we have a reliable weighing scale, weighs the same person at 150 pounds, what is that, 70 kilos-ish, 68 kilos, and not reliable is scales that vary each time you weigh yourself. Yeah, this is not a reliable scale. So reliability is basically consistency. Now, what can contribute to inconsistency, class? There are a range of factors that can limit the reliability of a measure. Yeah? Noise can come from many places. It can be noise due to the job candidate. Yeah? Their physical and mental health, motivation, level of stress, etc. all affect the reliability of the measure. Yeah? Here's an example. The applicant got into an accident on the way to the test, and so they're distracted during the interview process. Then you have unreliability due to the person administering the selection process. Yeah, so it's the person doing the interviewing, administering the test, administering the work simulation. Yeah, and so you can have one interviewer that smiles and one interviewer that's very kind of grim. Yeah, and that can have some effect that introduces noise into the selection process. And then we have the person scoring the selection tool. Yeah, if the way interviews are scored, the way assessment centers are scored is not consistent and clear, the people are not well trained, you can get noise that way. Yeah. And then of course there's the physical conditions under which the selection tool is given. Yeah, maybe it's too hot in the room, too cold, the lighting isn't very good, it's noisy, etc. All things that introduce noise and imprecision to our measurement, yeah, and that lower reliability. Now, class, when we say that reliability is consistency, we are specifically interested in 4 types of consistency. Yeah, test-retest reliability, parallel forms reliability, internal consistency reliability, and inter-rater reliability. Yeah. Now, some of these types are more relevant than others depending on the selection tool. But generally, that's the principle, is we want selection tools that are broadly consistent over time. Yeah. You assess them now, assess them a month later, should get roughly the same score. Consistent across forms. If you have 4 or 5 versions of the same, like math test, those 5 forms should give you roughly similar scores. You have consistency across items. So if you have a personality questionnaire with 10 questions about extroversion, all 10 questions should converge. Yeah. And then we have consistency across judges. Yeah. So if you have 5 people doing a panel interview, the 5 people should roughly agree on what a good answer is, and they should agree on how well each interviewee answer the questions. Okay, now, class, here's how we assess these things. Yeah? For test-retest reliability, we work out if the person scores at 2 different times, say now and a month later, whether these scores correlate. And this form of reliability is particularly important for ability testing. Then we have parallel forms, where we measure the same construct, yeah, the same predictor or the same criteria, with 2 different tests. And the scores should be very similar. This tends to be also important for ability testing. Then we have internal consistency. We compute something called coefficient alpha to work out if test items gel together. So if you have 7 questions about, say, customer orientation, all 7 questions should give approximately similar answers. Yeah? This tends to be common, especially for questionnaires, but also for interviews and assessment centers. Basically, any context in which you're asking someone for information about a construct multiple times. Yeah, it should be consistent. And lastly, Integrator Reliability is if you have two or more judges, they should agree on the quality of an answer during an interview, or the quality of a person's work if they're submitting a photography portfolio. Yeah, so this tends to be relevant for things like interviews, simulations, resumes, and references, where you kind of have to look at the resume and make a judgment call. Like, does this resume show evidence of possessing the KSAOs? And so you would want three people to roughly agree on their evaluation of the resume. If you have a system that has them agree, then you have good measurement of the resume. Yeah? Now, moving along, let's focus on test-retest reliability. So here we see an example of how test-retest reliability is assessed. Looking at how people respond to a programming aptitude test administered 1 month apart. And so, in principle, programming ability should not change drastically in the span of a month. Yeah. So, if this aptitude test if it were a good test, this construct ought to be measured consistently over short spans of time. So, scores should not vary a lot. You shouldn't see too many cases where someone responds. Takes the test the first time and gets a 68 and then gets a far lower score the second time around. Yeah? So here is how that can be evaluated. Let's say we have 5 people taking the test. We have their scores and then we work out their ranks. Yeah? Now, if they take the test again and so they take the test the first time and their scores are 96, 87, and so on, and you can rank them in order. They take the test again. There's some change in their scores, but their rank is the same. The same people score the highest, the same people score the lowest, yeah? In this case, we have good test-retest reliability. However, if the rank order moves around and the person who was nearly at the bottom before is suddenly close to the top, something is wrong. Yeah? Now, typically, when we do test-retest reliability correlations, what we like to see is a correlation of 0.5 or above. That's generally considered pretty good. Okay, and here we see it's 0.94. Very good. Yeah. Now, class. Obviously, not all constructs of interest are suitable to be evaluated with test-retest reliability. Yeah. I'm sure you can think of things that could meaningfully fluctuate from day to day or from month to month. Things like your mood or your energy levels. And so measuring mood or energy, it would be ridiculous to look at test-retest reliability. That sort of thing varies naturally over time or from day to day. Yeah. Another is learning in class. So if I were to give you a quiz now and then give you a similar quiz again in a few weeks, it wouldn't make sense to look for test-retest reliability because you will naturally improve from learning and experience. The whole point of teaching is for you to learn and so to develop your ability. Yeah, so you would not want test-retest reliability where you are expecting change. Now, the problem is when relatively stable constructs like intelligence show big fluctuations in measurement. Yeah? Like, you should not see a dramatic change in intelligent measurement from month to month. Something is wrong with the measure if that's the case. Yeah? So those big fluctuations, if they show up, could be indicative that the measure is tapping something that's more unstable, varying from day to day, like say anxiety. And so in that case, it's introducing noise into the measurement. Then we have another type of reliability that's particularly relevant for ability testing, called parallel forms reliability. So, class, you've probably heard of the IELTS, English language testing. Yeah, these like tests that international students have to take. Some of you may have taken them. Now, class, these English language tests are administered very regularly and they are different from week to week. So every time you rock up to take this test, it is a different test. Now, if you rocked up to take the test and it's the same every time, or it's the same reasonably often, what you'd find is that test scores would get contaminated because people would share answers, or there would be practice effects because you've taken the same test twice in a row, so naturally you'll do better the second time, yeah? To prevent that from happening, we develop a bunch of test items and look for parallel forms reliability. So basically, multiple versions of the same IELTS test should give an individual approximately similar results. Then we have internal consistency reliability. Yeah? So this is a fairly common form of reliability that's essential for any questionnaire-based testing, like ability testing or personality testing. If you've ever taken a survey and you've kind of wondered, hey, why are they kind of asking me the same question repeatedly? It's because multiple questions are being used and they're trying to work out roughly, is it consistent across these multiple questions? Yeah. So what we want is answering 5 questions about extroversion. People should give very similar answers to all 5 questions, approximately. Yeah. Now, we can work that out, calculate that, using 2 kinds of statistics, which you don't need to learn. But you should know what they are for the purposes of evaluating selection tools. So first is, if the test has correct answers, we use the Kuder-Richardson 20. Yeah, so this works out if, let's say we have 15 questions about, say, computing skills. And you have 15 multiple choice questions where there's correct answers. There should be consistency in how people respond to those questions. Yeah. Now, if the test has no correct answers, like a personality test or most personality tests will be like this, then we use something else called coefficient alpha, sometimes also called Cronbach's alpha, named after Lee Cronbach, the psychometrician from the 50s. Now, this Cronbach's alpha just works out basically how consistent are the answers across different items. And so it gives us a number ranging from 0 to 1, yeah, where the bare minimum is 0.7, yeah? And that's the bare minimum because the way we interpret the Cronbach's alpha is we square it, and that squared value gives us the ratio of signal to noise. So if you square 0.7, you get 0.49. So approximately 49% signal and 51% noise. That's why this is the bare minimum. For high-stakes testing, we like a Cronbach's alpha of 0.95. So class, when you, as we go through this semester, and as you start looking into selection tools on your own and learning about reliability, you'll find that Cronbach's alpha is by far the most commonly reported form of reliability. I'd say 90 to 95% of reliability indices are the Cronbach's alpha or the coefficient alpha. Yeah? So it's good to learn these rules of thumb. 0.7 bare minimum, 0.95 is what we want for high stakes testing. And the reason is, if you square the Cronbach's alpha, you get the ratio of signal to noise. And what we want is bare minimum approximately 50-50 signal to noise. Yeah? And again, the noise being captured here is noise from differences in the way items are worded, right? Like if you take a personality questionnaire, sometimes the wording of some items can be ambiguous or confusing. And so that can introduce noise, and Cronbach's alpha captures the extent to which that noise is problematic. Okay, here's how it's roughly computed. We have 3 items here, and we work out roughly how the items go together, how they correlate, where 0 is no correlation and 1 is a strong positive correlation. Yeah, we'll get into correlation more in a bit. And so basically, items that correlate pretty well together, approximately 0.5 or more, will gel together nicely, and so we get the average of the items correlating with each other, and then the average of everything else to roughly work out the reliability based on internal consistency. You don't need to know these formulas. I'm presenting this primarily for the high-level students who want to understand what goes into a Cronbach's alpha. Now, for the Cooder-Richardson, it's pretty similar. What we work out is the scores of the individuals taking the test and the number of test items gotten correctly, and we work out the ratios. Yeah, fairly straightforward. For Cronbach's Alpha, we have here 4 questions about conscientiousness. You rate yourself on the following 4 adjectives: dependable, organized, hardworking, and persistent. Yeah? And so what we find is this is a highly reliable measure where people are generally agreeing across the 4 items. They give this similar ratings. And here we have an unreliable measure where we're seeing dramatic fluctuations in how people respond to these 4 really similar items. Okay, lastly, we have Integrator Reliability. Now, class, if you're undergoing a panel interview, you want all 3 panelists to roughly agree on how good your answers are. Yeah? This consistency across panelists evaluating the interview is called inter-rater reliability, and we calculate it using an intra-class correlation. This type of reliability is also relevant for any expert judgment. So judgment of how good a portfolio is, or evaluation of a resume, of references. Yeah, in that to work out the consistency across evaluators, we assess inter-rater reliability. Now, class, like I mentioned earlier, there's a heap of things that influence the reliability of any measure. But I do want to draw attention especially to point E over here, the length of a measure. Generally, class, longer questionnaires with more questions that measure the construct are much more likely to be reliable. Yeah, the difference here is dramatic. 5 items, you get only 0.2, whereas with 80 items, you can get 0.8, for example. Yeah? Although typically you won't need that many items, but generally the more the better. And so, yeah, like I said earlier, if you're answering someone else's survey and you notice redundant questions, this is likely why. The more similar questions, generally, the more precise the measurement is going to be, the higher the reliability. Now, this becomes important, especially for high-stakes testing, when you're testing for something that is very, very important and very, very consequential. In such instances, you will really want a lot more questions and a lot of redundancy because the bar for reliability is so high. Yeah, and so every bit of noise makes it harder to find candidates who have the right KSAOs to do the job well and create value for the firm. Now, class, one thing to note is that reliability is a property of the group undergoing the measure. Yeah, it's not a property of the individual undergoing the measure. So, if you want to make claims, you need to calculate something called the standard error of the measurement, but you don't need to know this formula. Just so you know, this is a thing. Yeah. So we use the standard error of measurement to work out approximately how different 2 scores need to be before we go. So, like, if you're comparing 2 people's scores, you can kind of go, well, are the differences between their scores due to noise from low reliability, or is there a genuine difference here? Now, the way we do that is we calculate the standard error, and we say that if the 2 job candidates have scores that are at least 2 standard errors apart, then we can safely say that person X did score higher than person Y. However, if their scores are closer and are less than 2 standard errors apart, then we kind of go, well, maybe it's noise. We don't know. Yeah? And class, one thing you'll realize as you start preparing for your selection package assessment is that not all selection tools and the companies that develop these things, they are not often forthcoming about reliability information. What we find is that over 22% have no reliability information, 7% present nothing about reliability or validity, 9% will have reliability but not for certain subtests, yeah, and 28% have no normative data, so you have no norm comparison. So class selection is very much a business, and you will see a lot of selection tools out there that are simply not evidence-based at all, that are basically just capitalizing on, yeah, look, this seems fancy, let's use this, without it really being good measurement. So that's it for part 1 of this lecture. See you in part 2 for coverage of validity and utility.